Hey, it's Gentle K, your tech guide. Today we follow one HTTPS request from your code to the moment its first byte finally leaves. You paste in the code and AI wrote for you and run it. The key is right, the address is right, but instead of a response you get a red line. Certificate verify failed, then you open the server logs and it gets stranger. That server never received your request. Every character of your code is correct, and the request never left. An HTTPS request finishes its preparation before the first byte goes out. It finds a location from a name, and it checks that the other side is real while both sides settle on a key. Two things to take away today: what order that preparation happens in, and which gate to suspect when a certificate error shows up. Sending is not one action. One request has to clear 5 gates, and almost every error we look at today happens at the 4th. HTTP is how the web moves data around, and HTTPS is that with encryption on top. One more layer so nobody can read the contents without the key, and this is the default now. On public sites, more than 98% of the pages Chrome opens are already HTTPS. Find the address. Open the connection. Run the TLS Handshake. Check the identity, and only then send data. So let us follow a single request. From the moment your code calls that address to the moment the first byte really goes out, through all 5 gates in order. Of the 5 gates, only the last one moves your data. The first 4 are preparation. Gate 1 is finding the address. DNS turns a name into a real location. All we have is a name, and a network cannot go anywhere with a name alone. It needs a numeric location, an IP address. So the first thing that happens is a question. Where does this name live? Several layers answer that question, each one run by somebody different. It is like calling a company for the first time and having to track down the number first. Gate 2 opens the connection. A line goes up to port 443 at that IP address, and that line is the channel your data will travel through. It is the moment a phone call connects, before either side has said anything. Gate 3 is the TLS Handshake. A handshake is the short bit of setup where both sides agree how they will talk before the real conversation starts. Here that means settling on an encryption method they can both use and handing over key material at the same time. The client goes first. Here are the methods I support, and here is my material. The server picks one and sends its own material back. Those 2 messages build a key that only this connection will ever use. It works like agreeing on a private codebook that nobody else holds. That is half the preparation done. The road is open and the key is settled. But nobody has checked yet whether this is really who you think it is. Gate 4 is checking the identity. The server presents a certificate, and the client decides whether that certificate is genuine. A certificate authority, or CA, vouches for this server. It confirms the server really owns this name, and the certificate is the document that says so. The client checks this document on its own. It does not go back and ask the server. And if anything is off here, the connection ends. Before a single byte of your data has gone out. Gate 5 is the real conversation. Only now does actual data move, encrypted. Your first byte leaves only after all 4 gates are behind it. The 4th gate is worth opening 1 layer deeper. What the client actually reads inside that certificate is where almost every error today comes from. The client looks at exactly 3 things on a certificate: the name, the issuer, and the dates. If even one is off, the connection stops right there. First, the name. A certificate lists every name this server may answer to. If the name you asked for is missing from that list, the check fails. You can see this for yourself. Open a site, click the small icon beside the address bar, and open the certificate. The name of the site is written right there under Issued To. Second, the issuer. Who vouched for this document? And does your device trust that issuer? This is the heart of it. Someone else signed off on this server, and that signature is what makes the document worth anything. On that same screen, the issuer field shows a completely different name from the site owner. Think of a document read out over the phone. What makes it credible is the authority that issued it, not the caller. Your computer and your phone ship with a list of authorities they trust, and if the issuer is not on that list, the client stops. Third, the dates. A certificate has a start date and an expiry date. If today is not between them, it fails. Most certificates run for a few months now. Short lifetimes are normal, and renewal is handled automatically. Pass all three and the connection goes through. And this one procedure does 3 jobs at once. It keeps the contents unreadable in transit, it proves the other side is who they claim, and it guarantees nothing was altered on the way. People reach for the padlock and think encryption, but identity is honestly half of it. So does all of this repeat on every connection? No. On the first connection, the server can hand out a session ticket. The next connection then starts from that earlier agreement. You reuse a key arrangement instead of building a new one. It is the next call where you simply agree to use the same codebook. That is why 5 gates do not make the connection feel slow. So, what does it look like when one of those 3 is off? This is the part where error messages start making sense. When an error comes up, do not open your code. The request never left. What you look at is the name, the issuer, the dates, and DNS. Your code never runs the handshake itself. Code libraries like Request or Axios handle gates 2 through 4 for you. All we write is one address starting with HTTPS. So when a certificate error comes up, there is nothing in your calling code to fix. That is the first fork in the diagnosis. A certificate is issued for a domain and installed on servers. A domain is a name, and a server is the machine actually doing the work when you follow that name. So 10 servers sharing one domain still need only one certificate. You copy the same file onto all 10. Symptoms split 2 ways. Things that block you while you're building, and things that kill something that was already running. Start with the ones that block you while you build. Certificate does not match domain. That is what you get when you swap the address for an IP. The IP is not on the list of names in the certificate. This is exactly why you call by name even when you know the IP. The browser throws this one. Your connection is not private. The document exists, but your device does not trust the authority that issued it. You see this a lot with internal tools. Then there is the one where it works locally and fails after deployment. The connection went up fine, and the 4th gate cut it off. A local address does not use encryption at all, so that gate was never there to begin with. Now the ones that kill something already running. These are worse because nothing in the code changed. It worked yesterday and it does not today. The certificate expired, automatic renewal seemed fine, and it had quietly stopped. Users report they cannot log in, but the cause might sit at gate 1 instead of anywhere near the login code. I hit this myself once. A logistics company ran a customer portal, and reports came in that login was broken. The cause turned out to be DNS. The name of the symptom on the screen and the layer that actually broke can be completely different. And do not switch off certificate verification just to move faster. The error message goes away, but so does the whole check on whether the other side is genuine. Somebody flips it on during testing, and it ships that way. That really happens. Here's how that judgment actually sounds on a team. One Slack thread, right after a deploy.
Staging is fine, but production throws an SSL error on the same call. The calling code is literally identical, so I am lost.
You do not need to look at the code. The request never went out. Does the error message show a domain? Start with whether the name we are calling matches the name on the certificate.
Oh, the production config has the address hard-coded as an IP. Could we just disable verification?
That is not fixing it. That is switching off the identity check. Point it at the domain. If it still errors after that, go look at the certificate dates.
3 questions come up every time. How SSL and TLS relate to each other, what a certificate costs, and who actually runs a DNS server. So what is the difference between SSL and TLS? SSL was the original name, and TLS is the successor. Everything running today is TLS. SSL was retired more than 10 years ago, and only the name stuck around, which is why the file people call an SSL certificate is actually used by TLS? Who issues certificates, and do they cost money? A certification authority, a CA, issues them, and getting one for free through an automated process is completely normal now. Let's Encrypt alone went from serving 492 million sites to 762 million in a single year. Unless you need your organization verified too, free is plenty. Is a DNS server public or private? It is several layers, each with a different owner. Some layers are run by the domain owner, and some by an internet provider or a public DNS service. So who fixes it depends on which layer the answer got stuck at. Next time a certificate error shows up, the name, the issuer, the dates, and DNS are what you reach for. Here they are in 3 lines. 1. An HTTPS request clears 5 gates before it sends anything. Only the last one is actually talking. 2. Certificate checking looks at 3 things: the name, the issuer, and the dates. 3. When an error shows up, do not open the code first, look at those 3. Turning the check off only removes the error, not the risk. And that's everything for today. I hope this one helped. If it did, I'll see you in the next one. That's it from Gentle K. Thanks for watching, and remember, just start. It's easier than you think.